Hello everyone and welcome to Electronic Technocrat. Our today's video will be the continuation of part 1 of stack memory, arrays and pointers. So if you haven't watched our previous video yet, I will wait over here till then you complete the part 1 and continue with the part 2. Now, in order to store the array, it could had also be written as like this. So we could have written instead of writing it each element inside the array, and you could just specify the size of the array by putting the size over here. We want 5 elements inside the array, so that is why the size of the array is 5. And I could just input the elements like this. So I have to just add the index 0. I want my value to be 1. At index 1, I want my value to be 2, and so on. So in this way also we could initialize our array or each element inside the array. Okay, so this was another way in order to initialize the array. Now let's move on, and I will just clear my screen, and again let's see what else do we have to cover. So now, as I told earlier, we have something else also in C programming language, which is of really helpful and important concept in C, and that is known as pointers. So pointers are really a special type of variable which will store the address of another variable. It might look cryptic at first, but it is really important. I will just show you a program of pointers in C programming language. So as you can see, I have defined a variable and also initialized it with a value a. So this is a char type variable. Okay. And I've also initialized an pointer. So this is a pointer, and the pointer is initialized to a null value, because if I don't initialize the pointer at its declaration, it will store memory address of any location. Okay, so we don't want to do that, and that is also known as a wild pointer. So we don't want a wild pointer, we have created a null pointer, so it is not pointing anywhere else, and the value if we want to print over here, it will always be 0 because it is not pointing anywhere in the memory. Okay, so it is automatically initialized to 0 by the compiler itself, but we want it to point to something. So that's why in this statement it will point the variable p, or my pointer, to the memory address of this variable c. Okay, and do you remember this ampersand sign now? This ampersand sign just allocates the memory, whatever the memory this c variable is residing to this variable p. Okay, and now I have some print statement over here, which will just validate whatever I am saying. So it will first print the value whatever is present in the c by using the format specifies %c and the variable as c, and also it will print whatever the address the c variable is stored on. Okay, and this ampersand sign again, because I want to print the address of the variable c rather than its value. Now again, I will just print whatever the value is inside my variable p, and hopefully it will be the address of the c, because that is what I want. And I will also print the address of p, which will be something different apart from the address of C. Okay, now let's verify this program by running it. Okay, so again, I will compile this program. Okay, I will just say ptr, and I will just run ptr0.c. Okay, everything compiled, looks good. And yes, now again, we will see the value in C is a, which is what we have initialized our variable to be. Now the address of the variable C is this. It will be different for you if you run the same program, and whatever the value in the p is actually the address of the my variable c. Okay, so you can see over here it's really same, or it's exactly the same. And address of the p variable is something else, because our pointer is defined in some other memory location, or is in some other static variable memory location. Okay, and if you want to visualize it diagrammatically, over here I have made a diagram, so you can clearly see the value in C is A, and the address is something something AF. Okay, that is important. The LSB part only. And you can see in the variable P, or my pointer P, I have the value same as what was the address of my pointer, or what was the address of the variable char. Okay, and the address of my pointer P is something else, which is different from the variable C. Okay, so that is important point, that my variable P is holding whatever the address is of my variable C. So I will just show you another program in which we have made use of that address. Okay, and that is ptr1.c. Okay, so over here I have taken an integer type variable I and I have initialized it to 10, and then again I have created an integer type variable or pointer P and initialize it to null. And this is important to note that whatever is the data type of the variable of which the address you want to store or of which you want the pointer to point, it should be same. As you can see, I have the data type of I as int, so my data type of the pointer should also be of integer type. And in the previous program my data type of C was char, so that's why the data type of pointer was char. Okay, so that is really important to note that if my integer data type is there of the variable which I want to point to, then the pointer data type should also be of int. And in order to make a variable as pointer, you have to put this asterisk symbol. Unlike the ampersand symbol, this just tells that whatever the variable I'm going to use is a pointer rather than a simple variable. Okay, so this few things you have to keep in your mind. Now, what I have done is I've used some printf statement, and in the first printf statement, you can see I'm just printing the value of whatever is in I. So this was a well-known statement to all of us. Now I have stored whatever the value is inside the variable I using the pointer. So what I have done is, since the p is having the address of the variable I have used this asterisk symbol to print whatever the value is present at that particular address. Okay, so whatever might be the address of I, it will just go there because due to this asterisk symbol, it will just go over there and it will find what is stored at that particular address. So this asterisk sign over here is acting as a dereference sign. So it will just dereference whatever the value or whatever the address is stored in the P and will give actual value at that particular address. Okay. And again, I have printed the value of I using another method in which I have used the ampersand sign and a dereference sign. So what this does is ampersand sign will actually give me the address of the variable I. But since I'm using the dereference sign as well, what it will again do is it will go to that particular address and print whatever the value is of I. So they both actually cancel each other, if I were to say. Okay, and again, now I have printed the address of variable I using that ampersand sign. Address of variable I can also be printed by just printing whatever the value is present at the location P, because pointer points to that particular address itself. And I have also printed the address of the pointer P by using the ampersand sign. Okay. So remember, always whenever we have to print the address, we have to use ampersand or sorry, percentage %p format specifier. And in order to assign the value or assign the address of a particular variable, we have to use ampersand. Okay. And in order to make any variable as a pointer, we have always used this asterisk symbol. Okay. Now let me just go ahead and run this particular program. I will first compile it. I will just say it again ptr, but this time I will compile ptr1.c and compiles. And as you can see, the output is what we want. The value of I is 10 in 3 different methods. We have printed the value of I, and we have even printed the address of I using 2 different methods. Okay, and we have finally printed the address of variable P or the pointer P. Now let's see what all application or in which application this pointer can be implemented. Okay, now I will just go ahead and clear my screen. And now let's see what next program we are going to take. So the next program will be function ptr0, ptr0.c. Now what this function does is really simple. Now, rather than creating a pointer to a variable, we have created a pointer to a function. So a C program also allows to create a pointer to a function as well. Okay. So what I have done is I have created a function prototype of sum. So this is just prototype of function sum. An actual function is written down below. It just takes two input a and b, and then just returns a plus b, whatever is the summation value. Okay, so that is just the function prototype over here. Now inside the main, I have created a pointer towards the function. Now how to create this pointer? First, the return type must be same of that of which the function you want to point to. So the return type of my function to which I want to point it to was int. So that's why the return type of this pointer to the function is also int. Now to make a variable, or to make a pointer to point towards the function, first you have to tell the compiler that I have created not a variable but a function pointer. So to do that, you have to enclose the name with the asterisk symbol inside the parentheses. So that tells the compiler that whatever you are going to do or whatever you are going to create is not a pointer to a variable, but to a pointer to the function. So that is how you tell the compiler that this is not a pointer to a variable, but rather this is a pointer to the function. And then you have to create, or you have to give the formal arguments of that particular function. So in this case, the formal arguments were int and int. So that's why these are my formal arguments. And again, I have initialized this whole to a null. So it won't point to any unknown memory location, because you don't want our program to crash due to this. So that's why it's always good to park. So this is also known as parking the pointer. So I've parked my pointer to point to the null value. Okay. And now in the next statement, I have actually initialized that pointer, or I have actually initialized this function pointer. So to initialize the function pointer, we have used same the address of symbol, and since the function name is also actually the address of that particular function, so instead of using this ampersand symbol, we could have just even used the sum word. So if you neglect this ampersand sign, it will still work. Okay, so that is how you initialize that function pointer. And then I've created an integer sum which will just hold with this sum value, and I have called this function. Now, rather than calling the sum function directly, what I have used is a function pointer. So what I will do is I will write the name of that function pointer and pass the actual arguments now. Okay, so these actual arguments are 10 and 20. Now, since the function name, as I already told, is pointing towards that address, so we don't even need this asterisk symbol even. So we don't need that dereferencing. The compiler will automatically dereference our function pointer. So we could have even just simplified it even more and just even wrote that function underscore ptr 10 and 20. So this is as good as this whole statement. Okay, so we don't need the dereferencing as well. And I have then finally printed whatever the value is of sum, and then return 0 because everything succeeded. Okay, so let me just go ahead and run this program as well. So I will just call it function ptr now, and function ptr 0.c. Okay, and now I will just run it. As you can see, as expected, 10 plus 20 is 30. But this time I have called the function pointer and not the function name itself. Now let me go ahead and show you one another program in which we have used the pointers to pass the value of variables. Now let's see what this function is, or what this program is. Now this is a very well-known program. It is used to swap two numbers. So I have over here again defined a function prototype swap, and what I have used is, rather than passing the value or passing the variable as by value, I have passed them by reference. Okay, so you can either pass the function or the arguments to the function by value or by reference. So over here, I have passed them by reference. To pass them by reference, you have to initialize, or you have to use pointers. So this formal arguments, inside the formal arguments, or inside this what you say prototype, I have used two pointers. Okay, so now in the main, I have two variables a and b, and they are storing like 10 and 20. So I will first of all print whatever the value was before swapping, and then I will just call the swap function. Now to pass values, or to pass the whatever variables to the swap function, what we have to do is we have to first prefix each variable with this ampersand sign, because the compiler at the compilation will give error, because these are pointer and not variables. So pointer always require addresses and not values. Okay, so that's why we have pass the addresses of these variable a and b by using this ampersand sign. Okay, and then inside the swap function, what it does is it will take that addresses and will store in these two pointer pa and pb, and these both are integer type pointers. And what I have done is created a variable named as temp to just hold temporary data. And this, what the temp does, it first it will take whatever the value is present at this address pa, because this pa is pointing to the address of variable a. So by using this asterisk symbol or the dereferencing symbol, I will get whatever the value is present at that address. Okay, so my address, whatever the value stored is 10. Okay, so at this particular location I have value stored as 10. Now that is stored inside now the 10. Now whatever the value is stored in the pb address is given to pa. Pa's what you say address. So in the pb holds the address of variable b, and by using the defense it will just point towards the value stored inside that address. So what it does is assigns the value of 20 to pa, and then it will assign the value of temp to pb. So that, which in this case was temp, was holding the value of a, so it will just go into b. So that's how you swapped it. And now after swapping, I will just print the result. Okay, so let me go ahead and compile this program as well, and I will just name it like this, and 1.c. Okay, and now I will go ahead and run this program. Okay, so as expected, before swapping, the value of a and b were 10 and 20 respectively, and after swapping they have become 20 and 10 respectively. Okay, so that is how we have used the pointers to point towards a function or to point towards a variable, and even we have used pointer to pass the values by reference to a function. So that's all for today. Thank you so much for watching. Thanks a lot. Bye and take care.